The river, singing its jungle past, roaring its ocean future, taking and giving power. The Atlantic washes gently against the coast, enticing the river away from the land. This is Zaire, nearly 1 million square miles of jungle, steppes, and savannas. It produces most of the world's cobalt, much of its copper. But further development of mineral resources awaits power. So a bold plan was born to bring today's most advanced technologies to a region once described as the heart of darkness and give it light. It would take the power of a massive river, change it to volts and watts, and send it on shimmering strands across Zaire to help build a nation. To transmit power 1,700 kilometers from the Inga hydroelectric development on the Zaire River to the mineral-rich Shaba region where it was needed, 3 companies pooled their skills and resources to design and build the world's longest extra-high voltage direct current intertie. Linked firmly to African tradition, the 23 million people of Zaire are moving ahead. After centuries of tribalism, decades of colonialism, and the turbulent years of early independence, a new national purpose has taken hold. Most of the people still live in small villages, still rely on farming, still use the natural waterways for transportation. But under the leadership of President Mobutu Sese Seko, nearly 200 tribes have been melded into the second largest nation in Africa. Today, the people are eager for new challenges and the rewards of a bright future. Kinshasa, the capital of Zaire, embodies this spirit. Aware that social progress is linked with industrial development, the government of Zaire has fostered new commerce, new planning for growth. Half a world away in San Francisco, detailed planning for the transmission line got underway. At International Engineering Company, a subsidiary of Morrison Knudsen Company, a team of specialists studied the scope of the Zaire project. AICO, Fishbeck and Moore International Corporation, and Morrison Knudsen International Company joined together to form a consortium to handle the job. The consortium was sponsored by Morrison Knudsen and called Constructeurs Inga Shaba. CIS was awarded a fee-type turnkey contract that included all design engineering, procurement of all materials, and construction of the entire system. the project assumed global dimensions. For financing, MK helped bring the government of Zaire together with export credit institutions from two countries, the U.S. Export-Import Bank and private U.S. banks. As design progressed, purchase orders went out to hundreds of suppliers. The sophisticated converter equipment would come from Sweden. Part of the towers would come from Italy. U.S. firms would supply all the rest. As the planning took shape in San Francisco, attention was already being paid to the time when the system would be turned over to the Zaire government, ready to operate. With the cooperation of the U.S. Bureau of Reclamation and the Bonneville Power Administration, training began in Denver, Colorado for employees of SNEL, Société Nationale d'Électricité, the Zaire government agency which awarded the contract and would operate the giant network on completion. At Boise, Idaho, world headquarters of Morrison Knudsen, a group of experts began solving the logistics problems posed by construction needs in uncharted parts of equatorial Africa.
Flying only, night flying at Kinshasa, possibly tonight.
Altogether, more than 140,000 metric tons of material and equipment had to be shipped from dozens of ports and arrive on time at sites where few people had ever been. But they were there now.
Kwako matiti mamingi, mboti tukulumuka kuna tuweko makulini. Sebia mboti tukulumuka kulini.
Survey teams dropped by helicopters checked the route of the transmission line and marked for those to follow where the double file of tall steel towers will march. Parts of the 1,700-kilometer path across Zaire yield reluctantly to machete and axe. Before construction of the actual transmission line can begin, a right-of-way 80 meters wide must be cleared. In the ripe jungle, progress is difficult. The task is easier on the high steppes and savannas of the African plain. Here, mechanized equipment can replace human sinew to clear the earth. Section after section, the work continues, until finally the route is cleared, waiting for the steel. Months earlier, men on the shores of the Pacific began making what men on the shores of the Atlantic would need. At a steel plant on the west coast of the United States, the interlocking tower parts are formed, manufactured to precise specifications. As a representative of SNEL looks on, some of the 55,000 metric tons of galvanized steel is prepared for shipment. The conductor cable for the transmission line is being made at another U.S. plant. A steel core wrapped with 45 strands of aluminum and more than 3 centimeters thick will carry the high voltage. Spooled onto heavy reels, the conductor cable will be loaded, along with the many hundreds of other needed items, onto freighters for the long voyage, halfway around the world. Their destination is the port city of Matadi, 125 kilometers up the Zaire River. This is the transatlantic terminus, and the docks of Matadi bulge with the arrival of more supplies, more equipment. At Zaire's modern capital city of Kinshasa, farther east, the Zaire headquarters of CIS directs the flow of materials to staging areas. Here, the logistics of supply are felt firsthand, and tight control is established. Here also, the engineering designs created an ocean and a continent away come to life. To link all parts of the project, a radio communication center is established. As work moves farther from existing transportation links, new ways are found to move men and supplies and equipment where they're needed.
Barge to Ilebo, by rail to Kananga, and by rail and/or road on down to Kolwezi.
CIS will build dozens of bridges, and where bridges aren't practical, ferries must be used to cross the many rivers of Zaire. The heavy electrical equipment for the converter stations at each end of the transmission line requires another solution. So 4 self-propelled barges ranging up to 70 meters in length are designed and built. Two of the barges are equipped with stiff-leg cranes, capable of handling such items as the 110-ton rotors and transformers for the synchronous condensers destined for the southeastern terminal. Part of the journey will be by rail, so special railroad cars are built. With this special rolling stock, existing rail lines can now move tons of supplies through parts of Zaire. To supply other sites, CIS will build or improve over 6,000 kilometers of roads for convoys of heavy trucks. Where neither rail nor road can be used, airplanes and helicopters handle the job. Rivers play an important part too. Zaire's 9,000 miles of navigable waterways allow the barges to move even more equipment. The logistics are staggering. One journalist called it the 8th wonder of the world, the Inga Rapids, where the Zaire River drops 335 feet in less than 10 miles, form an ideal hydroelectric site. This is a key to Zaire's economic growth. With a flow second only to the Amazon, the power potential of the Zaire River has only begun to be tapped. When fully developed, the Inga Power Complex could have an electrical output of nearly 40 million kilowatts. With a fraction of the power generated here and transmitted across the country, Zaire can double its refining and smelting capacities in Shaba and become the free world's foremost supplier of copper. Other metals could follow.